The coastal landscape is a dynamic environment, perpetually shaped by the processes of erosion and deposition. Waves play a crucial role in sculpting these landforms over long periods. Understanding the interaction between wave action and coastal geology is essential to comprehend how various coastal features are formed. Coastlines can be classified based on the arrangement of rock layers relative to the shoreline. Concordant coastlines have rock layers that run parallel to the shore, resulting in a more uniform coastline as waves encounter similar resistance along the shore. In contrast, discordant coastlines have rock layers that run perpendicular to the shore, leading to differential erosion. This differential erosion creates alternating headlands and bays, with harder, more resistant rock forming the headlands that jut out into the sea and softer, less resistant rock forming the bays that indent the coastline. Headlands are subjected to intense wave erosion, resulting in the creation of dramatic coastal features such as caves, arches, and stacks. Erosion processes like hydraulic action and abrasion exploit weaknesses in the rock, such as joints and cracks, enlarging them to form caves. Continued erosion deepens these caves until they break through the headland, forming arches. Over time, the roof of the arch collapses due to gravity and further erosion, leaving behind isolated columns of rock known as stacks. These stacks are eventually reduced to stumps and eroded away completely. Cliffs are another prominent feature of coastal landscapes, constantly eroded by the action of waves. Waves erode the base of a cliff through hydraulic action, abrasion, and corrosion, creating a notch at the cliff base. This notch causes the upper part of the cliff to become unstable and collapse, resulting in the formation of a wave-cut platform. As the cliff retreats, this flat, rocky platform is left behind at the base, extending several meters into the sea and becoming exposed at low tide. Beaches, on the other hand, are formed by the deposition of sediment brought in by waves. Constructive waves, characterized by a strong swash and weak backwash, transport and deposit sand, pebbles, and other sediments along the shore. The size and composition of beach material can vary, with sand typically found on more sheltered beaches and pebbles on more exposed ones. Beaches often have a gentle slope and can feature berms, ridges of sand or pebbles created by wave action. Deposited sediment also forms various coastal features, including spits, bars, and sand dunes. Spits are elongated ridges of sand or shingle extending from the coast into the sea, formed by longshore drift. This process occurs when waves hit the shore at an angle, transporting sediment along the coast. Spits often curve at the end due to changes in wind or wave direction. In some cases, a spit can extend across a bay, connecting two headlands and trapping a body of water behind it, known as a lagoon, thereby forming a bar. Sand dunes are formed when the wind blows sand inland from the beach, depositing it in mounds or ridges. Vegetation, such as marram grass, stabilizes the dunes by trapping sand and reducing erosion. Dunes often form parallel to the shoreline and can move over time, creating a dynamic landscape. The coastal landscape is a testament to the powerful and dynamic processes of erosion and deposition by waves. From the dramatic cliffs and headlands to the gentle slopes of beaches and the intricate formations of spits and bars, these features are constantly shaped and reshaped by natural forces. Understanding these processes helps to appreciate the complexity and beauty of coastal environments and highlights the importance of managing and protecting these areas from the impacts of natural forces and human activities.